get free gifts cards now. This we have discussed in the example. So how the neuron process data in the neural networks, this we have discussed in the last lecture. We have discussed कर चुके हैं. Output layer and the final classification we have discussed by example. We have discussed this email classification example in which we need to identify a mail on the keywords free, win and offer. Which consists of an input layer and the hidden layers. We are identifying here the two neurons S1 and S2, and after combining it, the span probability in the output layer. So we have divided this email classification into three layers. So then we are saying the how the classification can be and what are the types of a neural network. Right? We have done till this topic. We have done learning of a neural networks, how the neural networks learn, learning with the supervised learning, learning with the unsupervised learning, and learning with the reinforcement learning. And that we after that we discussed about the types of a neural network. This we need to discuss, and the implementation of a neural network using a TensorFlow. This create a neural network, compiling the model, train the model, make the predictions, complete for the implementation under the NumPy and the Panda of a Python library, right? So this code need not to be done. Now what is need to be discussed here? Now the neural networks are widely used in many different applications because of their benefits. This we need to discuss today, and after that we will discuss about the genetic learning. And then we will summarize both and complete our 4th unit completely. And then we will start our 5th unit, in which we need to discuss about the expert systems. A simple the AI applications, and we will discuss about the expert systems. So what the neural networks are? Neural networks are widely used in different applications because of their main benefits. The link between the inputs and the outputs is very complex, which are not well defined, because they cannot adapt to new situations and learn from the data, right? Because in the neural networks, we are talking about the mimic of a human behavior. And as the human learn in the new situations with the help of its own experience and learn from the data which is present on the environment. Likewise, the neural networks are used for that kind of activities where the input and output is linking between the input and the output is very complex, and it is not well defined, and the system need to be adapt to the new situation and learn from the data. Then another application is for the pattern recognition, where there is a need of a pattern recognition. So another benefit in terms of a neural network, we are talking about the pattern recognition. So their proficiency in pattern recognition renders them efficiencies in tasks like the audio and the image identification, or simply in the pattern recognition, we are talking about the natural language processing and the other intricate data patterns also. Then we are talking about the parallel processing. Because the neural networks are capable of a parallel processing, we have discussed in the last lecture also, in the working of a neural network, we have discussed about the term that the data is distributed, and then the data when the data processing and the data that will be in a parallel. So as the networks are capable, as the neural networks are capable of parallel processing by nature, that can process the numerous job at the once, which speeds up and improves the efficiency of our computation. Then the non-linearity. As here, the linearity is not a concern. Or simply we are saying that neural networks are able to model and comprehend complicated relationships in data by the virtue of non-linear activation functions found in the neurons, which overcome the drawbacks of the linear models. Then the disadvantages of a neural network. Neural networks, while powerful, are not without drawbacks and the difficulties. First is we are talking about the computational intensity. Large neural networks, here we are talking about the computational intensity, where the connectivity between each and every process and then parallel processing that data, and the computational is very demanding there. So the computational intensity will be very high when we are talking about the large neural networks. The large neural network trainings can be laborious and computationally demanding process that depends on a lot of a computing power. Another disadvantage, we are talking about the black box nature. What do you understand about the black box nature? As the black box model neural networks pose a problem in an important application science, it is difficult to imagine how they make their decisions. So we don't know much about the environment here. Then the overfitting. Overfitting is a phenomenon in which the neural networks commit training material to memory rather than identifying patterns in the data. Although regularization approaches have to elevate this, the problem still exists here. Need for a larger data sets. For the efficient training, neural networks frequently need the sizable labeled data sets. Otherwise, their performance may suffer from the incomplete or the skewed data. So we need a larger data sets to understand. And if we talk about the applications of a neural network, we are saying that it is used in the image and the video recognition, natural language processing, finance, healthcare, gaming and automation systems, autonomous. So the image and the video recognition here. Complex neural networks are extensively used in the applications such as the facial recognition, CNN, autonomous driving in the medical image analysis. Natural language processing, or the RNN retrieval, here we are talking about, and the transformers, power language translation, chatbots, and the sentiment analysis. Then we are saying the finance, predicting stock prices, fraud detection, and the risk management is the another application in the finance and the healthcare. Neural network assist in diagnosing diseases, analyzing medical images, and personalizing treatment plans. Gaming and the autonomous systems, neural networks enable real-time decision making, enhancing user experience in the video games, and enabling autonomous systems like self-driving cars. So till now we have discussed about the neural networks or the neural network learning. If we are talking about the neural network learning, I'm switching a screen from this neural network to the specific topic of our video, which is a neural network learning. We are talking about here. We are converting this a biological neuron into an artificial neuron for the perception of a linear class. Somewhere we are talking about the perceptron. The perceptron, an invention of a 1962. Rosenblatt was one of the earliest neural network models. Also, it models the neurons by taking a weighted sum of its input. As we have discussed about the basics of a neuron or the neural network, now we are talking about the typical terms that comes under the neural network learning. First, we are talking about the here. So how it works, it models a neuron by taking a weighted sum of its input and sending the output 1 if the sum is greater than some adjustable threshold value. Otherwise, it sends 0. So based on a condition with a particular threshold value, we are giving the output in terms of a 1 or a 0. Here in the diagram, you can see the biological neuron and an artificial neuron also, where we are talking about the perception. And here, perception with the adjustable thresholds we are discussing. With the sum of this all inputs here, the activated function of our can we give a output. This figure is showing how the perception will work, what is the neuron, and our neuron or a perception figure here is working with the help of a various threshold adjusted. In case of a 0, with the two inputs W0, W1 x1 plus W2 x2 is equal to 0, and x2 is equal to W1 divided by W2 x1 minus W0 W2 equation for a line, and the location of the line is determined by the weight 0, 1, and 2. And if an input vector lies on one side of the line, the perception will be the output form. And if it lies on the other side, the perception will be output. So what do you understand by this? Moreover, the decision surface aligned that correctly separates the training instances corresponds to a perfectly functional perception. So perceptron learning algorithm in terms of our neural network learning algorithm, we are talking about the perceptron learning algorithm. What is given here? Given a classification problem with the inputs of these features, input features of x1 to xn and the two output classes here. This is given. Now we need to compute a set of a weights from W0 to Wn that will cause the perceptron to fire whenever the input fall into the first output class. So we are having the two output classes 0 and 1. First step is create a perceptron with the n plus 1 input and the n plus 1 weight, where the x0 is always set to 1. Okay. Then second step is initialize the weight from W0 to Wn to random real values. Okay. Then the third step is iterate for the training set. Here we are talking about the training set and the iteration we are talking about, or the looping we are talking about, collecting all the examples misclassified by the current set of the weight. If all the examples are classified correctly, output the weight and weight. अगर सारे ही weight properly classified हैं all examples में, तो output the weight and fit the system. Otherwise, compute the vector sum S of the misclassified input vectors, where the each vector has in the form of x0 to xn. In creating the sum, add to S a vector x if x is an input for which the perceptor incorrectly falls to fire, but x if x is an input for which the perceptor incorrectly fire, multiply the sum by the scale of factor. So moreover, modify the weights. If there is a modification after performing the fifth step by adding the elements of a vector S to the them. And then go to step 3 again for the iteration of the training set to classify correctly, to classify all the examples correctly. So these steps we need to learn for the perception algorithm in the neural network learning. You need to remember this perception learning algorithm or the neural learning algorithm. This can be asked in your exam. Then the perception learning algorithm is a search algorithm. What we are searching here, we are searching for a correct or misclassified or the classified examples correctly. It begins with a random initial state and finds a solution state. So the search space is simplify all the possible assignments of a real value to the weight of the perception, and the search strategy is gradient descent here. So what we are talking about here, that it is totally when we are talking about the perception algorithm, it is a search algorithm to search for a particular solution state. The perception learning rule is guaranteed to coverage to a solution in a finite number of steps, so long as solution exists. This we have talked about in the benefits of also in the neural network learning basics. Moreover, this brings us an important question: what problems can the perception solve? Recall that a single neuron perception is able to divide the input space into two regions. Also, the perception can be used to classify the input vectors also that can be separated by a linear boundary here. We can call such vectors linearly separated. Unfortunately, what we are saying here, many problems are not linearly separable in the neural network. So the classic example is the XOR gate. It was the inability of the basic perception to solve which such simple problems that are not linearly separable or non-linear. So here the possibility will be. So here we are taking an example of a neural network learning neural network that is in our syllabus. We have discussed about the complete neural networks and the algorithm also under the perception. Now we need to discuss about the genetic algorithm or the genetic learning. So what is a genetic algorithm? I am switching to the genetic algorithm or the genetic learning model. So what is a journal learning model? First we talk about, if we are talking about, we need to talk about the neural network learning. or the journal learning model and the genetic learning model. What do you understand by the journal learning model? क्या मतलब होता है journal learning model का? Learning can be accomplished using a number of different methods. First, we are talking such as the memorization facts, by being told, or by studying the examples like the problem solution. We have talked about the different types of a learning. Learning requires that new knowledge structures be created from the some form of a inputs stimulus here. So this new knowledge must then be assimilated into a knowledge base and be tested in some way for the utility also. We are talking about here the testing means that the knowledge should be used in the performance of some task from which the meaningful feedback can be obtained. And that feedback, where the feedback we are defining, which provides some measures of accuracy and usefulness of a newly acquired knowledge. So simply, if the question will be asked in your exam related to a genetic learning model, what diagram you can talk about here? We are talking about it. Environment of a teacher, stimuli examples, knowledge base, performance component, response, and the critic performance evaluator here. So journal learning model is depicted in a 4.1, where the environment we are talking about, where the environment has been included as a part of our overall learning system. We need to be learned from the environment, or the AI system for which we are talking about the learning, that need to be, there should be a environment which is included as a part of our overall learning system. And the environment must be regarded as either a form of a nature which produces a random stimuli, or as a more organized training source such as a teacher, which provides carefully selecting or selected training examples for the learner component. So here we are talking about learning by advice also. So the actual form of environment used will depend on the particular learning styles. What type of environment here we are talking about, with the help of what type of a learning has been used by a system. So in any case, some representation language must be assumed for the communication between the environment and the learner, and the language may be the same representation scheme as that used in the knowledge base, such as a form of a predicate calculus. We have talked about all this. When they are housing to the same, we say the single representation trick is being used, and this usually results in a simpler implementation, since it is not necessary to transform between two or more different representations. So this is your journal learning model. Here we are talking about, for some system, the environment may be a user working at a keyboard, right? Some human has been interacting with the system, or other system will use the program modules to simulate a particular environment. Somewhere we are talking about a programmer who is giving the instructions. Somewhere we are talking about a user who is giving instructions through the keyboard. In even more realistic cases, the system will have a real physical sensors with interface with some word environment. So the system will use the program models to simulate a particular environment. In more realistic cases, the system will have a real physical sensors with interface with some word environment here. So input to the learner component may be a physical stimuli of some type, or a descriptive symbolic training examples. The information conveyed to a linear learner component is used to create and modify the knowledge structures in the knowledge base. And this same knowledge is used by the performance component to carry out some task, such as solving a problem, playing a game, or classifying an instance of some concept here. So here we are taking an example, or we are saying that what is the feedback? So given a task, the performance component produces a response describing its action in the performing the task, and the critic module then evaluates this response related to an optimal response here. We are just talking about the figure that we have just seen. So feedback is indicating whether or not the performance was acceptable, is then sent by the critic module to the learner component for its subsequent use in modifying the structures. In the knowledge base, the data will be get modified according to a new knowledge. And if the proper learning was accomplished, the system performance will have improved with the changes made to the knowledge base. So the cycle described above may be repeated a number of times until the performance of a system has been reached to some acceptable level, until a known learning goal has been reached, or until changes ceases to occur in the knowledge base after some chosen number of a training examples have been used. So there are several important factors which influence a system ability to learn in addition to form of a representation used. They include the type of a training provided, the form and the extent of any initial background knowledge, the type of a feedback provided, and the learning algorithm used. So the type of a training used in a system can have a strong effect on a performance, much the same as it does the human, and the training may consist of a randomly selected instance. So the training set, when we are forming a training set or the system is forming a training set, that must be consist of a randomly selected instance or an example that have been carefully selected and ordered for the presentation. The instances may be a positive example of some concept or a task being learned. They may be a negative also, or they may be a mixture of both positive and negative. So the instance may be well focused, using only the relevant information, or they may have a certain variety of facts and details, including the irrelevant data also. That all depends on an environment. There are many forms of learning that can be categorized as a search through a space of possible hypothesis or the solution. We have talked about the different types of a learning in our unit. To make learning more efficient, it is necessary to constrain this search process or to reduce the search space. Definitely, if we need the optimal solution and the efficiency of a system should be more, then we need to select a proper search process. One method of achieving this is through the use of a background knowledge, which can be used to constrain the search space or exercise control operation which limit the search process. So whenever the feedback is there, feedback is very essential to your learning purpose. Why? So that the knowledge should be updated time to time, and then system will learn from the environment time to time. The feedback is very essential to the learning component, since otherwise it will never know if the knowledge structures in the knowledge base were improving or not, or they were adequate for the performance of a given task. Feedback may be a simple yes or no type of evaluation, or it may contain more useful information, describing why a particular action was good or bad. Also, the feedback may be completely reliable, providing an accurate assessment of the performance, or it may contain a noise. That is, feedback may actually be correct, incorrect some of the time. Intuitively, the feedback must be accurate more than 50% of the time, otherwise the system carries useful information. The learner should also be build up some useful purpose of a knowledge quickly. On the other hand, if the feedback is noisy or the unreliable, the learning process will be very slow and the resulting knowledge will be incomplete. So we have discussed about the learning by the neural network, and the last topic that we need to discuss is the genetic learning. So after this topic, we will complete our fourth unit. So what is the genetic learning that we need to discuss? Genetic learning is the supervised learning, or the supervised learning here we are talking about is the machine learning task of inferring a function from the labeled training data. Moreover, the training data consists of a set of training examples. Okay. So in supervised learning, we have talked about many of times about the supervised learning. So simply what we are saying is that in supervised learning, each example, a pair of consisting of an input object, typically a vector, and the desired output value, also called the supervised signal. Training set. A training set is a set of data used in the various area of the information science. to discover potentially predictive relationships that can be predicted for a new data. Training sets are useful in artificial intelligence, machine learning, genetic programming, intelligent systems, and deep tech. In all these fields, a training set has much the same role and often used in conjunction with the test sets. Now, what is a testing set? A test set is a set of a data used in the various areas of information science to assess the strength and the utility of a predictive relationship. Okay. Moreover, the test sets are used in artificial intelligence, machine learning, genetic programming, and statistics. And all these fields are test sets has much the same here as we have talked about in the training setup. So accuracy of a classifier. When we are talking about classifier in field of a science, engineering, industry, and the stats, accuracy of a measurement system is the degree of a closeness of the measurement of a quantity to that quantity's actual to value. Then in the genetic learning, we are talking about the sensitivity analysis of the supervised learning. Similarly, the local sensitivity as a correlation coefficient in the partial derivatives can only use if the correlation between the input and the output is a linear here, as we have talked about in the neural networks also. Then we are talking about the regulation or the supervised learning in statistics. Aggregation analysis is a statistical process for estimating the relationships among the variables. Moreover, it includes many techniques for modeling and analyzing the several variables. Then the focus on the relationship between a dependent variable and one more independent variables also. And more specifically, the regression analysis helps to one understand how the typical value of a dependent variable can change and when any one of the independent variables varies. So, moreover, while the other independent variables have fixed values.